All right, you had a worksheet. We'll go over a couple of these problems today, graphing wise, so we're all on the same page, what we need to do. Is there any in particular on the front that you would like me to go over before I choose one? I'll give you the first option, yeah. Number four. Problem number 4. We have y equals -2 minus 3 cosine of theta minus 30. Nope, minus 60. Okay, if you have not completed this problem, you should be doing this as we go along. Okay? If you're not completed, you should be doing it. If you haven't done it, please do. Find the amplitude, period, vertical, yes. Yeah, plus 60? Yeah, you're exactly correct. Should I doubt you? Okay, you want to find your amplitude, the period, vertical phase shift, horizontal phase shift, and the y-intercept. Once again, y-intercept, we put theta is equal to 0, so your theta value is equal to a value of 0. So once again, if you've not done it, please do it. And this process that we go through each and every time, should be going through each and every time as you're dealing with your graphs. It does not change. Mason, what's the amplitude and what's the period?
-3 and 360.
Now, if we take a look at the amplitude is the absolute value of the A value. So we don't throw the negative with that, we just keep it as 3. Okay, so it's still 3. And 360, we have our B value. That's out in front there, is a value of 1. And just to go back over, y equals vertical phase shift plus or minus the amplitude sine or cosine B theta minus horizontal phase shift. That is a constant throughout each one of these problems. Vertical horizontal phase shift. Aubrey, what do you have?
For vertical phase shift, I have -2,
And horizontal.
-60 degrees.
That's correct, because we have theta plus 60. We have to see the value that's being subtracted from 60. The value that's being subtracted from 60 is a -60, so that gives us our plus 60. And then our y-intercept. Mel, what do you get for the y-intercept? -3.5. You good with that? All right. Now we go to our graph. Looking at our graph. Let's see, I have an amplitude of 3 and a vertical phase shift of -2. So I need to be a little bottom heavy here. Not too much, but a little bottom heavy. Because I need to go down 2 and then down 3 more. But I need to have some space up top from the y-axis. Horizontal phase shift of -60 and then 360 degrees so I can space out by my 90s. So if I go count out by 90s. 270, I made one of these a little too big, but x-axis, here's my y-axis. And once again, need to be able to go down to at least 5. And then I can divvy up my 90s into thirds. Hopefully you're getting better at getting your graphs down and spacing out your graphs. It's not gonna be perfect, as you can see. My 90s, this one's probably a little skinnier than it needs to be here, but it's close. These are pretty good over here. First thing we look at, what is the first thing we look to draw on there, Trenton?
The BPS.
Okay, vertical phase shift. Okay, so we look at our prime axis. It tells us at -2. We're drawing our theta prime axis. Second thing we take a look at, what's the second thing we look for here, Sean?
The horizontal phase shift.
Horizontal phase shift tells us our theta start value, and also what else?
The peak or the valley.
Peak or valley, or on the prime axis, so we have to look at our trig function. Okay, so we look at our trig function, and this tells us our theta start value. So we have our theta start value at -60. The trig function, sine or cosine, tells us to start either on the prime axis or a peak or valley. Well, if I have a cosine here, what do we have with the cosines? At prime axis or peak or valley, Braden?
Peak and valley.
Peak and valley, well, we have to decide then, is it gonna be at a peak or the valley? What tells us if it's a peak or valley?
The horizontal phase shift being negative or positive.
That's correct, not the horizontal phase shift,
Or the, yeah.
the amplitude, what Machen was trying to throw into our amplitude there. That negative will tell us, do I go to my peak or go to my valley? Well, the negative will tell us to go to our valley. So at -60, here's my -60, I had to go to my valley value. Okay, so looking at the valley, what would be the y value at that valley? Cadence, what would be the y value? I'm starting at -60 and I have to go to my valley, so what y value would that be? -5. So I come down here -5 because I have to have my amplitude of 3 here. So I'm down at -5. The third thing we take a look at is the period. Tells us number of degrees until we reach the exact same spot again. So if I'm at -60 at -5, that's where we start at. Where do we end up at, Mia?
270.
270. If I'm at -60 and I go out 360 degrees, I'm at 270.
Wait, sorry. Wait. No, 300.
300.
Sorry, I read my
That's
notes
okay.
wrong.
So at 300, I'm going to drop down to -5. Now we start playing our games of halves. Okay, halfway point between 300 and -60. Okay, between two valleys, your games of halves, and you should be getting used to this now mentally. Between any two valleys, I have a peak. Between any two peaks, I'm going to have a valley with my games of halves. Between a peak and a valley, I have to cross the prime axis. So between any two valleys, I have to be at a peak with my game of halves. Any two peaks, I have to be at a valley with my games of halves. And my games of halves between a peak and a valley will cross the prime axis. So my halfway point between 30 and -60. What's our halfway point between that, Victoria?
120.
120, what's our y value?
1.
The value of 1, I need to be at a peak. Okay, then in my games of halves, I'm between a peak and a valley, I have to cross the prime axis, or peak and valley here, cross the prime axis, valley and peak over here, cross the prime axis. So I'm going to play my games of halves 2 more times. If you haven't done it, go ahead and do it. And both these points will cross the prime axis. Isaac Wenger, what do we have?
30.
30 would be 1. And what's the other one? 210 is the other. We could throw in our y-intercept and negative 3.5. And the graph should naturally flow through that. So looking at my graph, I got a valley. I'm going to come up through my y-intercept, hit my peak, and curve back around again. Any other questions on the front? All right, on the back, page problem 5 and 6. Now putting the process in reverse. Let's take a look at number 6. It's not exact, but it'll be close enough for me today. All right, we need to get amplitude, period, vertical, horizontal phase shift. Once again, we shift back to our base equation. Our base equation, y equals our vertical phase shift, plus or minus the amplitude, sine, cosine, b, theta minus horizontal phase shift. So looking at a graph, we need to find these tidbits of information. We need to find the amplitude, the period, which gives us the b value, vertical phase shift, and horizontal phase shift. Once again, our prime axis and vertical phase shift is the first thing we're going to do. Okay, so what I want you to do, we have the peaks and we have our valleys. The vertical phase shift, we want to draw in our prime axis so we have something to oscillate about. Draw in your prime axis if you have not done it already. And once again, that has to be a line that's going to divide our graph into two top and bottom equal level balanced graph. It's not going to be symmetric because we don't have symmetry there, but we're going to be able to go up the same amount and down the same amount. Riley, where are we gonna draw that in at?
-3.
-3. So at -3, we will draw on our prime axis. So that gives us our vertical phase shift at -3. The next thing we should be able to find is we should be able to pull out the amplitude. Okay, what is the distance from my neutral axis to my peak, neutral axis to my valley? So our amplitude's the next thing. Coulter, what's that gonna be?
3.
The value of 3. Because if I go from -3 to 0 or -3 to -6, that's going to be my amplitude. Okay, the next thing we want to find is the period. How we calculate the period is to go from peak to peak or valley to valley. How many degrees are there from peak to peak or valley to valley? The peaks are going to be a little bit easier because they hit your theta axis there. If I look at my two peaks, I got -60 and I got 180 degrees. What's the number of degrees between those two values? Mason? 240. So the period is 240. Now the B value, once again, as we talked about here, the period is calculated by 360 divided by B. So if we multiply both sides by B, these would cancel. So we have peanut butter is equal to 360. Well, to calculate the B value, we can divide by the period. So B is equal to 360 divided by the period, which in this case is 240. So we have 360 divided by 240. That's a fraction we can reduce. We can cancel zeros out. Cancel our zeros out, and then reduce 36 over 24. And what do we get for the B value? Courtney, what do you get for the B value? I'm sorry, what? 3/2. So we get 3/2 for the B value. And then we have to pick a horizontal phase shift. And once again, as we do this, there's infinite number of solutions to these equations. Infinite number of equations to write down. It depends on what you pick as your horizontal phase shift. But what should be true for each one of these values, or each one of these equations I see, the vertical phase shift should be the same. The A value should be the same. The B value should be the same. These three values should be the same. The horizontal phase shift may or may not be the same. And then your trig function, sine or cosine, depends if you take your peak or valley or on the prime axis. Okay, in which direction do I have a positive or negative there? Once again, my suggestion to you is just find a peak. So your equation is always a positive cosine. But if you want to advance yourself and use this value here, that's fine too. So if we take the peak at -60, when we're at a peak, positive cosine. When we're at a valley, it's a negative cosine. Okay, when you have a sine curve, you just have to watch which direction you're going. Okay, am I going up first and back down, or down and back up? That's why it's always easier just to pick a cosine to me. But if you use this value here, that's fine also. So throwing in our information, we have y equals our vertical phase shift, which is -3. Since we're going to a peak, I have a positive cosine. I have my amplitude of 3. Cosine, my B value, which is 3/2. Theta minus our horizontal phase shift, which is theta minus a -60. And this boom changes out to +60. So we have theta plus 60. Anybody use the horizontal phase shift to 0? Is it 0? What's your equation?
Y equals -3 minus 3 sine of 3/2
it just sort of cleans it up a little bit, you don't have an extra value there. But I'm going down first and back up, very good. Going down first, back up, so we have a negative sign. Once again, if you start to see and realize those things right there, you have a pretty good understanding of what you're dealing with respect to your graphs. Okay, you're thinking beyond just, okay, I'm just gonna go to what Mr. Gregory said in class. If I go to my peak, positive cosine, I can get my answer, which is, there's no problem with that at all. There's no problem with that, because it gives you a correct solution there. But once again, as you start to advance yourself and you start thinking in the math world, advancing yourself in the math world, you start seeing and realizing other things that occur with respect to our things that go on with math. Any other questions you have? Okay, what I'm going to do is I'm going to go one more day with the graphs here. Probably don't need it, but I'm still going to do it. I'm trying to slow down just a little bit to help out the people that aren't here today. So these graphs are very, not going to be the same graph, but just working through it. Oh, let's see. You know what I forgot to do? Darn it. I forgot your in-class assignment. Oh, bad me. Let's see if I can pull it up real quick. No. See, this is the advantage of teaching for like 1,000 years. Unfortunately, teaching for 1,000 years, I have 1,000 years worth of stuff here. But I will give you a little reprieve. You only have to do one of the two top ones. I'll be back in a second.
That was so funny.
Yeah.
How do you You do a problem, like you literally plug in the equation. So, yeah, I understand that, but how do you fit in this equation for the person? You just like, what is it, 4 times 30? You know what I'm saying about it? Yeah. No, you don't need to look at the I literally have a secret. I don't know. Get out, get off me. I think that's how you. Let me see. Maybe not. I don't know. Good freaking question. So, no, it's, this is how I was doing it. What is the period? Is it 90? Is the period 90? What? Is the period 90? Yes. It's 0.5 million, but
one of the two top ones. You don't have to do just pick one of the two. And do problem 3.